There is something sitting at the bottom of the largest freshwater lake in the world that does not belong there. Not according to the maps, not according to the history books, not according to anything we were ever taught in school. It sits in the cold, dark water, hundreds of feet below the surface, in a place that should contain nothing but silt and stone and the rusted bones of shipwrecks. And yet it is there, carved, arranged, deliberate, old in a way that makes the oldest European settlements in North America look like something that happened last Tuesday. Researchers who have dived those waters describe the experience of coming upon it in almost identical terms. A strange stillness, a feeling that something is watching back, a certainty that what they are looking at was not made by accident or shaped by water or wind. It was made by people, by hands, by minds that understood geometry and engineering and the weight of stone. People who were doing things on the edge of Lake Superior when the rest of the world would not have had a name for this continent for tens of thousands of years to come. And historians, the official ones, the ones with the degrees and the university appointments and the book deals, most of them still cannot agree on what to do with any of it. Some have quietly filed it away under categories like anomalous or requires further study, which is academic language for we have no idea and it makes us uncomfortable. Others have pushed back harder, insisting that the formations are natural, that human brains are pattern-seeking machines, and we see faces in clouds and cities in rock formations, and that is all this is. But the divers keep going down, the researchers keep publishing, the underwater photographs keep circulating, and the formations beneath Lake Superior keep refusing to be explained away. This is the story of what is down there, how it was found, what it might mean, and why the answer, whatever it turns out to be, should change everything you thought you knew about who was in North America before the history books say anyone was here at all. If you are watching this to fall asleep, that is exactly why I make these videos. Maybe subscribe and let me know where you are right now and what time it is. I always check the comments, and something about it never gets old. Someone in Vancouver at 2 in the morning, someone in Lagos as the sun is just coming up, someone in a small town in rural Minnesota who can actually see the stars tonight and is thinking about what might be buried under the lake 100 miles to the north. All of us connected across time zones, drifting off together to the same strange story about a lake that may have been holding one of the oldest secrets on this continent for longer than we have had the tools to even ask the question. The lake itself is worth understanding before we go any further, because Lake Superior is not the kind of thing that fits easily into the mind. You know it is large in the abstract, the way you know that space is large or that the ocean floor is deep. But knowing it and truly imagining it are two different things, and most people, even people who have lived their whole lives in the Great Lakes region, have never quite made peace with how enormous this body of water actually is. Lake Superior holds 10% of all the surface freshwater on Earth. Not all freshwater, surface freshwater. The kind you can actually access. The kind that rivers and lakes and streams represent. 10% of that entire global supply sits in this one lake in the middle of North America. If you poured Lake Superior out across the lower 48 states of the United States, you would cover every inch of land beneath 1.5 feet of water. The lake stretches for almost 400 miles from east to west. Its northern shore is in Canada. Its southern shore touches Minnesota, Wisconsin, and Michigan. Its surface area is roughly 31,000 square miles, which is larger than the entire country of South Carolina. And most people, when they stand on its shore, cannot tell the difference between it and the ocean. There is no visible far shore. The horizon is water in every direction. The waves during storms can reach 25, 30, 40 feet. Ships have been sunk on this lake that were purpose-built for the North Atlantic. The Edmund Fitzgerald, the most famous shipwreck in Great Lakes history, was longer than 2 city blocks and went down in Lake Superior in November of 1975, like it was nothing, like the lake did not even notice. This is not a quiet inland pond. This is something that behaves like a small, cold, deeply dangerous sea, and its depths, its true depths in places, approach 1,000 feet. The deepest point is somewhere around 1,332 feet below the surface, in a region called the Chippewa Basin. That is more than 1/4 mile of dark, cold, motionless water sitting between you and the bottom. At those depths, there is no light. There is almost no life. There is almost no current. Things that fall to the bottom of Lake Superior tend to stay there. They tend to be preserved in ways that things buried in soil or submerged in warmer, shallower, more biologically active water are not. The cold is severe enough, the pressure is intense enough, and the chemistry of the water is unusual enough that organic material, wood, rope, even human bodies in some documented cases, can be preserved in Lake Superior for extraordinary lengths of time with very little decay. This matters. This matters enormously for what we are going to be talking about, because if structures were built on the floor of Lake Superior, or if they were built on land that later became the floor of Lake Superior, those structures would have had the best possible preservation conditions on the continent, better than Egypt, better than the American Southwest, better than almost anywhere on Earth where ancient construction is found. The cold, dark water of Superior is one of the best accidental archives in the world. And the question that has been quietly haunting archaeologists and divers and independent researchers for decades is whether that archive contains something that should not exist according to the standard history of North America. To understand why what lies beneath the lake is so difficult to fit into the accepted historical framework, you have to understand what the accepted historical framework actually says about this part of the world, and more importantly, you have to understand some of the assumptions buried inside it that rarely get examined out loud. The conventional history of pre-Columbian North America has been revised more times in the last 50 years than in the entire previous century, and it is still being revised right now. When you were in school, you probably learned something like this. Humans crossed into North America from Asia via a land bridge called Beringia. Somewhere around 13,000 years ago, they spread south through a corridor between glaciers, and they were the first people here. That model was called the Clovis First hypothesis, named after a distinctive type of stone spear point found near Clovis, New Mexico in the 1930s. For decades, it was treated not as a hypothesis but as a settled fact. Clovis was the beginning. Everything else was later. Anyone who suggested otherwise was fringe, was amateur, was not serious. Then sites started appearing that did not fit. Monteverde in Chile, a site with strong evidence of human habitation dating to at least 14,500 years ago, before the Clovis people were supposed to have even arrived in North America. A site in Texas called Deborah Friedkin, with stone tools dating to potentially 15,000 years ago. Evidence from Paisley Caves in Oregon that pushed back human presence even further. Genetic studies of indigenous American populations suggesting the founding populations arrived not in a single wave, but in multiple waves, some of them quite early. The mainstream slowly, reluctantly, painfully began to accept that the Clovis First model was wrong. Humans had been in the Americas longer than 13,000 years. The question of how much longer remained, and still remains, genuinely open. But here is what this revision created. It cracked open a door. If humans were here earlier than we thought, then the possibility space for what they might have built, what they might have accomplished, what traces they might have left, becomes dramatically larger. And the things found in the waters and on the shores of Lake Superior start to fit into a very different kind of story than the one we were originally told. The copper that came out of Lake Superior changed everything once, a very long time ago, and barely anyone outside of a small community of researchers knows this story, which is extraordinary because it is one of the most remarkable episodes in the entire archaeology of North America. The Keweenaw Peninsula in Michigan, which juts into the southern part of Lake Superior like a crooked finger, sits on top of one of the largest and most accessible deposits of native copper in the world. Not copper ore that needs to be smelted. Native copper. Pure metallic copper sitting in the rock, sometimes in nuggets, sometimes in veins, sometimes in massive formations that can weigh tons. The copper in the Keweenaw is not locked up in chemical compounds the way most metal deposits are. It is just there, pure and workable, almost as if it was placed there for someone to find. And someone did find it. A very long time ago. The copper pits of the Keweenaw and Isle Royale, the large island that sits in the northwestern part of Lake Superior, represent what is almost certainly the largest prehistoric mining operation in the Western Hemisphere, possibly one of the largest prehistoric mining operations anywhere in the world. Archaeologists have documented thousands of ancient copper pits across this region, tens of thousands of stone hammers recovered from the sites. The scale of extraction that these tools and pits imply is staggering. Conservative estimates suggest that somewhere between 500,000 and 1.5 billion pounds of copper were removed from this region in ancient times. The numbers are difficult to even comprehend. 1 billion pounds of copper, extracted by hand, with stone tools, by people who left no written records, and no clear descendants who remember it happening. The dating of these mines has placed the most intensive extraction period somewhere between 5,000 and 7,000 years ago, though some evidence suggests activity as early as 10,000 years ago. This is the Old Copper Complex, the name given to the ancient culture or cultures that carried out this extraordinary operation, and the culture that emerged from it in the Great Lakes region. And here is the thing that makes archaeologists very uncomfortable when they talk about it publicly. No one knows where the copper went. 1 billion pounds of copper, extracted over thousands of years. And in the archaeological record of the Great Lakes region, in the villages and campsites and burial mounds of the cultures that lived here during that period, there is simply not enough copper to account for it. Not even close. The local archaeological sites contain some copper objects. Beautiful, well-made things. Tools and ornaments and weapons that show genuine metallurgical sophistication. But the quantity of copper present in the local record represents a tiny fraction of what was removed. So where is the rest of it? Where did 1 billion pounds of copper go? That question has been hanging over North American archaeology for a long time, and some researchers have suggested answers that the mainstream finds deeply uncomfortable, because those answers point across the ocean. The Bronze Age began in different places at different times. In the Near East and parts of Europe, it began roughly 5,000 years ago, give or take a few centuries. And bronze, the alloy that defines the Bronze Age, requires copper, lots of copper, and tin. And here is something curious. The European Bronze Age copper supply has never been fully accounted for. European copper deposits are real and were mined, but the quantity of bronze objects produced in Europe during this period vastly outpaces what the known European copper sources could have supplied. Researchers have actually run the numbers on this. The math does not work unless there was a copper source that history has not properly recorded. The Bronze Age Mediterranean world was genuinely hungry for copper in quantities that their local mines could not satisfy. And across the Atlantic, in a lake that barely anyone in Europe had ever heard of, there sat what may have been the single largest accessible copper deposit on Earth. There is a researcher named Gavin Menzies who pushed the idea of Bronze Age transatlantic contact quite aggressively, and his methods have been criticized, and some of his specific claims have not held up well. But the broader question he was circling around, the question of whether Bronze Age maritime cultures could have reached North America, and whether the copper trade could explain both the missing copper of Lake Superior and the unexplained bronze surplus of Europe, that question has not been refuted. It has been ignored, which is a very different thing. The distinction between a theory being disproven and a theory being unfashionable is one of the more important distinctions in the philosophy of science, and in the world of pre-Columbian contact studies, that distinction gets blurred constantly. The copper question sits at the heart of what makes the Lake Superior ruins so significant. Because if there were people here, systematically, over thousands of years, mining copper in industrial quantities, those people would have needed infrastructure. They would have needed places to live, to store equipment, to process ore, to organize labor, to conduct whatever rituals and ceremonies their culture required. They would have built things. And the question is whether some of those things ended up underwater. The water level of the Great Lakes has not been constant. This is something that geologists understand very well, and that archaeologists have been increasingly forced to reckon with as evidence for ancient activity along lake shores keeps turning up in places that are now well below the waterline. The Great Lakes system is young by geological standards. The lakes formed as the last great ice sheet retreated roughly 12,000 years ago, and in the period immediately following that retreat, the water levels were dramatically different from what they are today. There were periods when Superior was much lower. There were periods when it was higher. There were periods when it drained in completely different directions, through completely different outlets. The landscape that the first humans in this region encountered was not the landscape you see on a map today. It was shifting, changing, dynamic in ways that are difficult to fully visualize without sophisticated geological modeling. Researchers who study ancient shoreline dynamics have documented ancient beach lines around Lake Superior that now sit at various depths below the current water surface. Stone circles and what appear to be structural remains have been found at some of these ancient shoreline levels. The implication is that people built on land that was subsequently flooded, not by catastrophic events, but by the gradual rise and shift of lake levels over centuries and millennia. This is not a fringe idea. This is basic hydrology. The question is only how much was built, by whom, and what remains of it in a condition that allows us to recognize it for what it is. The answer, based on what divers and researchers have found, appears to be more than anyone was expecting. The stone formations that have attracted the most sustained attention and the most controversy are not the only anomalous structures in and around Lake Superior, but they are the ones that best illustrate the core puzzle. There are locations along the lake where large stones are arranged in patterns that do not correspond to any known geological process. Lines that run too straight, circles that are too regular, right angles in places where rock does not naturally form right angles. Structures that appear to have been modified, shaped, or assembled by something other than the random forces of erosion, glaciation, and geological upheaval. Some of these are above the waterline, hidden in dense forest on shores that are genuinely remote. You do not drive to these places, you take a boat to the shore, and then you walk for hours through terrain that has not changed much since the last glacier left. And in those forests, in places where the undergrowth pulls back and the bedrock is exposed, you find them. Arrangements of stone that look like walls, depressions that look like they were dug. Circles of upright stones in configurations that remind people, inevitably and uncomfortably, of other stone circles on other continents. Some researchers have noted alignments with sunrise and sunset at the solstices. Others have noted that certain formations appear to mark directions or distances in ways that suggest intentional measurement. The local Ojibwe and other Anishinaabe peoples have oral traditions about these places that predate European contact by an unknown but substantial length of time. Those traditions describe the stones as sacred, as markers, as places where something important happened or continues to happen in ways that their cosmology encompasses, but that Western scientific frameworks struggle to accommodate. The relationship between indigenous oral tradition and archaeological evidence in this region is complicated, politically sensitive, and genuinely important. The traditions did not arise from nothing. They arose from long presence in this landscape, from observation, from memory that was maintained and transmitted with great care across many generations. When those traditions point to a feature of the landscape as significant, that is data. It is not the same kind of data as a carbon date or a microscopic analysis of stone tool marks. But it is data, and dismissing it entirely because it does not fit the expected categories has led researchers astray before in North American archaeology. There is a specific underwater formation that has been the subject of more focused investigation than almost anything else associated with the Lake Superior mystery, and it was not found by professional archaeologists. It was found by a recreational diver. This is a pattern that repeats itself with uncomfortable frequency in the world of anomalous archaeology. The professional institutions are not looking because the theory says there is nothing to find, so the amateurs look. And sometimes the amateurs find things. The diver in question was exploring a section of the lake floor in relatively shallow water, shallow by Lake Superior standards, maybe 40 or 50 feet down. The water visibility in that part of the lake, depending on conditions, can be surprisingly good. He was following a section of the rock shelf when the formation became visible, and he stopped. The stones were too regular. They were arranged in a configuration that he could not attribute to the random settling of glacial debris. There was clear, angular consistency to the layout. There was what appeared to be work stone that had been shaped rather than simply broken, and there was scale. The formation extended for a considerable distance in a direction that suggested something deliberate, something that had a beginning and an end, defined by intention rather than by geological chance. He documented it as best he could with the equipment he had. He reported it, and for some time the report went nowhere, which is the other pattern that repeats itself constantly in this field. Amateur finds something, reports it. Institutional response is minimal. Formation sits uninvestigated. The amateur community passes the information around among themselves, accumulating more documentation, more dives, more photographs, until eventually either the formation becomes too well documented to ignore, or it becomes the foundation of theories that the mainstream can dismiss as conspiracy, precisely because the mainstream declined to investigate it properly. When the opportunity was there, it is a cycle that serves no one, and it is one of the most frustrating aspects of trying to understand what Lake Superior actually contains. The geology of the Lake Superior Basin adds another layer of complexity to the discussion, because the bedrock in this region is genuinely ancient in ways that make the geological context of any man-made modification very difficult to establish. The rocks that form the basin of Lake Superior are among the oldest exposed rock formations on the surface of the Earth. The Precambrian shield that underlies much of the Canadian side of the lake contains rock that is more than 2.5 billion years old. The volcanic formations of the North Shore, the basalt flows, and the copper-bearing rocks of the Keweenaw are somewhere around 1 billion years old. These are not young rocks. These are rocks that have been shaped by forces and timescales that are essentially incomprehensible from a human perspective. And this creates a real challenge for researchers trying to identify human modification in this landscape. When your substrate is ancient basalt and greenstone that has been cracked and folded and moved by forces operating over billions of years, distinguishing between a natural fracture and a worked surface requires a level of expertise and a quality of investigation that takes time and funding and institutional support, all of which has been in short supply for anyone working on the Lake Superior anomalies. This is not a technical problem that cannot be solved. It is an institutional problem that has not been prioritized. The difference is important because it means the mystery is, at least in part, a mystery by default. We do not know what these formations are, in part because no one with the full resources of a major research institution has made it a priority to find out. And the reason no one with those resources has made it a priority is that the mainstream framework says there is nothing significant to find. The circularity of that logic is something that a number of researchers have pointed out with increasing frustration over the years. If you travel to the North Shore of Lake Superior and you talk to people who have lived there for a long time, indigenous people, commercial fishermen, people whose families have been on this lake for generations, you will hear stories that the academic literature tends not to engage with. Stories of stone structures found and then covered up, or found and then quietly reported, and then found to have disappeared from the report by the time any follow-up investigation was attempted. Stories of divers who went down to specific coordinates and came back talking about things they could not explain, and then declined to speak publicly about it after conversations with people they declined to name. Stories of researchers who began asking the wrong questions and found their funding quietly redirected. Some of this is certainly the normal folklore that accretes around any genuine mystery. The human tendency to narrate conspiracy around the unexplained is very real and very powerful. But not all of it is folklore. There are documented cases of archaeological sites in North America being investigated, documented, and then effectively buried in reports that are technically available but practically inaccessible, filed in ways that ensure they will never be encountered unless someone knows exactly what they are looking for. The politics of pre-Columbian archaeology in North America are genuinely, documentably contentious in ways that have real effects on what gets investigated, what gets published, and what gets treated as settled fact. The story of the Kennewick Man is a useful example, not because it is directly related to the Lake Superior formations, but because it illustrates the way institutional politics can delay scientific investigation for years. When an ancient skull was found along the Columbia River in 1996 with physical characteristics that did not fit the expected profile of early Native American populations, the response from various institutional actors was not to investigate more thoroughly. It was to fight over custody of the remains for nearly a decade while the scientific questions remained unresolved. The controversy was real, the politics were messy, and the underlying science eventually produced genuinely important findings that changed the picture of early North American population history. But it took decades to get there, and it got there only because a small number of researchers refused to accept the institutional roadblocks as final answers. The copper culture of the Great Lakes did not appear in a vacuum. It emerged in the context of a broader pattern of sophisticated cultural development in North America that the standard historical narrative has consistently undervalued and underexplored. The Poverty Point site in Louisiana, which dates to roughly 3,500 years ago, represents a level of earthwork construction and social organization that would require thousands of workers acting in organized, sustained coordination over a long period of time. This was not a simple village. This was something closer to a ceremonial and commercial center of genuine scale, serving a regional network of communities spread across a wide area. And it was built by people who, according to the standard framework, were simple hunter-gatherers without the social complexity needed to organize projects of this magnitude. That framework has been revised, but the revision has not fully filtered down into the popular understanding of pre-Columbian North America. The Cahokia Mounds in Illinois, built between roughly 900 and 1400 years ago, represent an urban center that at its peak may have had a population of 10 to 20,000 people, which would have made it one of the largest cities in the world at that time, larger than London, larger than many cities in Europe. Built entirely by people who had no contact with, and no influence from, European civilization. These are not obscure findings. These are established, well-documented archaeological realities, and they sit alongside the Lake Superior Copper Complex as evidence that the pre-Columbian history of North America is vastly more complex and more impressive than the history taught in most schools. The formations beneath the lake need to be understood in this context. They are not isolated anomalies floating in a vacuum. They are potential pieces of a much larger picture of early North American civilization that has been systematically underestimated. The oral traditions of the Anishinaabe peoples, who have lived around Lake Superior since before recorded history, and whose oral tradition extends their presence in this region back considerably further than European contact, contain descriptions of a time before the current world, a time when the landscape was different, when the water was in different places, when the relationship between land and lake was not what it is now. These traditions describe beings and events and places that most Western interpreters have treated as purely mythological, as metaphorical accounts of a spiritual reality, rather than as encoded memories of actual historical events. But there is a growing body of research suggesting that oral traditions, particularly those of indigenous peoples with very long, unbroken chains of transmission, often contain accurate information about events that occurred far in the past. The Aboriginal Australians, for example, have oral traditions that describe specific geological events, coastline changes, and landscape features that can now be confirmed through geological analysis. These traditions describe events that occurred 10,000 years ago or more, and the descriptions are accurate, not approximately accurate, not metaphorically accurate. Geologically accurate in ways that require the traditions to be carrying real information about a real observed world across hundreds of generations. The Anishinaabe traditions about the transformation of the landscape around Lake Superior, about structures and places that are now beneath the water, should be read in this light. They are not necessarily myth. They may be memory, and if they are memory, they are pointing towards something that the geological evidence of changing lake levels independently supports, that there was habitation in places that are now underwater, and that the people who lived there knew it and remembered it, and passed that memory down in forms that their descendants still carry. There is a concept in archaeology called the coastline problem, and it is increasingly recognized as one of the most significant blind spots in the entire discipline. The basic issue is this: for most of human prehistory, coastal areas were the most desirable places to live. Coasts and lake shores offer the most diverse and reliable food resources. They offer transportation corridors. They offer the kind of moderate climate that comes from proximity to large bodies of water. And in North America, at the end of the last ice age, the coastlines and lake shores were dramatically different from what they are today. Sea levels were lower, lake levels were different, the actual shorelines were in completely different places. The most intensively inhabited areas of 12,000 years ago, 10,000 years ago, 8,000 years ago, are now in many cases underwater. This means that for the period when humans were first establishing themselves in North America and developing the earliest forms of organized society, most of the evidence for where they lived and what they built is submerged. It is not gone, in many cases. It is just underwater. And underwater archaeology, particularly in cold, deep, low-visibility environments like Lake Superior, is extraordinarily difficult and expensive. It requires specialized equipment, trained personnel, careful methodology, and institutional support, all of which requires funding that requires someone to decide that looking is worth the cost. And someone will only decide that looking is worth the cost if they believe there is something to find. And they will only believe there is something to find if the existing theoretical framework allows for the possibility. Which brings us back to the circularity. The formations beneath Lake Superior are not being adequately investigated, in part because the theoretical framework says they cannot be what they appear to be. And the theoretical framework is not being challenged by investigation because the formations are not being adequately investigated. The only way to break this cycle is for enough evidence to accumulate through informal, underfunded, amateur-led investigation that the mainstream can no longer credibly decline to engage with it. And that is exactly the slow, painful process that appears to be underway. When divers have managed to photograph and document the formations in detail, the images raise questions that the geological explanation struggles to answer. There are surfaces that appear worked, not merely flat, which can happen in certain kinds of rock under certain geological conditions, but worked in ways that suggest deliberate shaping. There are corners. Right angles are not common in nature. Geological processes that produce flat surfaces rarely produce them at right angles to other flat surfaces without human intervention or very specific and well-understood geological conditions. When right angles appear in the wrong geological context, they are significant. The formations in Lake Superior contain what appear to be multiple instances of right-angle junctions in configurations that should not occur naturally in that specific geological setting. There are what appear to be tool marks. This is technically the most significant category of evidence, because if the stone surfaces carry marks consistent with the use of stone or metal tools, that would be essentially conclusive evidence of human activity. Analysis of potential tool marks requires physical access to the stones and sophisticated microscopic analysis of the surfaces. That kind of analysis has not been conducted systematically on the Lake Superior formations. It has been conducted on some surfaces found along the shore above the waterline, and the results have been contested. The mainstream position is that the marks are natural. The researchers who documented them say the marks are inconsistent with natural processes. The argument goes on while the formations sit in the dark water, holding their secrets. The question of who built things on and around Lake Superior requires engaging with a history of human occupation in this region that extends much further back than most people realize. The standard timeline in American school textbooks has indigenous peoples arriving in the Great Lakes region somewhere in the range of 10 to 12,000 years ago, which aligns with the post-Clovis migration models. But there is evidence, not yet fully accepted by the mainstream but accumulating, that human presence in the region goes back further. The archaic peoples who occupied the Great Lakes region beginning roughly 10,000 years ago were not newcomers in any simple sense. They were the descendants of populations that had been in North America long enough to develop highly specialized adaptations to this specific landscape. And the people who mined copper on the Keweenaw and Isle Royale, beginning roughly 8 to 10,000 years ago, were not simple foragers stumbling upon a resource by accident. They were organized. They had sophisticated social systems that could coordinate large-scale labor. They had technological knowledge specific to copper processing that had clearly been developed over a long period of time. You do not figure out how to anneal copper, how to work native metal into complex shapes, overnight. That knowledge represents hundreds or thousands of years of experimentation, trial, error, and accumulated expertise. The people who developed it had been here long enough to develop it. And the question is what else they built, what else they made, what traces they left in the landscape beyond the copper pits, which are dramatic and visible enough that they could not be ignored. The formations beneath the lake may be part of the answer to that question. There are other unexplained things associated with Lake Superior that do not always get discussed in the same context as the underwater formations, but that belong in the same broader conversation. The lake is associated with a higher than average rate of unexplained disappearances of ships and aircraft. The Great Lakes generally have a poor reputation in this regard. The Edmund Fitzgerald is the famous case, but it is not isolated. Dozens of ships have disappeared in Lake Superior under conditions that do not fully account for their loss. The lake's behavior in extreme weather is genuinely different from the behavior of other bodies of water of comparable size, partly because of its depth and temperature dynamics and partly because of the speed with which weather systems can change in the region. None of this requires a supernatural explanation, but the reputation of the lake as dangerous, as unpredictable, as somehow aware of the people and objects it swallows, is very old. It predates European contact by an unknowable span of time. The Anishinaabe name for the lake is Gitchigami, or in some transliterations, Kitchigami, and it translates roughly as Great Sea or Great Water, with a connotation of power and presence that goes beyond the merely physical. The French voyageurs, who learned everything they knew about navigating these waters from indigenous guides and partners, shared the indigenous respect for the lake's capacity for violence. The lake is personified in the oral traditions of multiple cultures that have lived along its shores, and it is not personified benevolently. It is personified as something powerful, capricious, and not entirely knowable. Whether or not any of this has anything to do with what lies beneath the lake's surface, it is part of the cultural context in which the mystery of the formations has always existed. The lake has always been a place where the boundary between the known and the unknown is less clear than in most places. Let us talk specifically about the structure that has received the most sustained attention from the research community, such as it is. In the western arm of Lake Superior, in relatively accessible water, there is a formation that has been documented by multiple independent divers over the course of several decades. The formation consists of large stones arranged in what appear to be linear configurations extending for dozens of feet in a consistent direction. The stones are not randomly distributed. They are not piled in the way glacial debris piles. They are positioned the way you would position stones if you were building a wall or a foundation, with relatively flat surfaces facing upward and with consistent spacing. Divers who have studied the formation have noted that the individual stones appear to have been selected for size and shape compatibility, which is exactly what you would do if you were choosing building materials for a specific purpose. You would not use whatever happened to be nearby. You would choose stones that fit together, that offered the stability and the surface quality you needed. The stones in this formation show that kind of selection. They are not a random sample of the available rock in the area. They are a curated collection, and they are arranged in patterns that the divers and researchers who have examined them consistently describe as architectural. The word that comes up again and again in the documentation is intentional. Whatever these stones are, they were arranged intentionally. The argument about whether that intention was human or geological continues, but the formation itself is real, is documented, and is not going away. The context of similar discoveries elsewhere in the Great Lakes region strengthens the case for taking the Lake Superior formations seriously. Lake Michigan, which is connected to Lake Superior through Lake Huron and the Straits of Mackinac, has its own underwater mystery. In the Grand Traverse Bay area in northern Michigan, sonar scanning of the lake floor in 2007 revealed an arrangement of stones at a depth of roughly 40 feet. Among those stones was one that appeared to bear a carved image, specifically a carving that some researchers identified as consistent with a mastodon. Mastodons, the large proboscidean relatives of mammoths, went extinct in North America roughly 10 to 12,000 years ago. If the carving on the stone in Grand Traverse Bay does depict a mastodon, and if the carving is contemporaneous with the animal's existence, then the stone is at least 10,000 years old. And if it is 10,000 years old, it was placed in its current location before the lake reached its current level, which means it was placed on dry land by people who lived in a landscape that no longer exists. The researcher who reported this finding, Mark Holley of Northwestern Michigan College, was appropriately cautious in his public statements. He did not claim certainty. He claimed the need for investigation. The investigation that followed was limited. The story generated significant media interest for a brief period, and then essentially disappeared from mainstream coverage. The formation is still there. The questions have not been answered. They have simply been set aside. One of the most striking aspects of the Lake Superior mystery is how much of the relevant evidence was gathered not by professional archaeologists working within institutional frameworks, but by recreational divers, amateur researchers, and indigenous knowledge keepers whose testimony and documentation often operates outside the channels that academic archaeology uses to validate claims. This is not unusual in the broader world of unconventional archaeology, but it creates a genuine epistemological problem. The evidence exists. It has been gathered. It has been documented in photographs and video and written accounts. But because it was gathered outside the institutional framework, it does not count the same way. It goes into a different pile. It gets treated with a different default level of skepticism. This is understandable from a methodological standpoint. Science has standards for good reasons. Systematic documentation, peer review, replicability, these are not arbitrary bureaucratic hurdles. They are the things that separate reliable knowledge from plausible story. But in a situation where the institutional framework is actively declining to investigate, demanding institutional quality evidence as a precondition for institutional investigation creates an impossible standard. You cannot produce institution quality excavation reports if no institution is excavating. You cannot produce peer-reviewed analysis if no peers are reviewing. The amateur community does what it can with what it has, and the mainstream uses the resulting methodological gaps to avoid engaging with the substantive questions. It is not a conspiracy. It is a structural problem, and it has the effect, whatever its cause, of keeping inconvenient questions from receiving the serious attention they deserve. The copper of the Keweenaw Peninsula and Isle Royale leads, in some researchers' thinking, to a question that goes even further back. The culture that mined that copper was not alone in the world. It was connected, through trade networks and through the movement of people and ideas, to a larger world of complex pre-Columbian cultures that stretched across North America. The Hopewell tradition, which flourished in the Ohio and Mississippi River valleys roughly 2,000 years ago, shows evidence of trade connections extending from the Gulf Coast to the Great Lakes to the Rocky Mountains. Hopewell sites contain obsidian from Yellowstone, copper from Lake Superior, shells from the Gulf, mica from the Appalachians. This was not a small local network. This was a continental trade system of considerable sophistication, and it was operating long before anyone from the Old World arrived on this continent. The people who participated in this network, who moved through it, who extracted and processed and traded the resources it depended on, were not simple primitives. They were sophisticated agents in a complex economic and social system. They built things. They organized things. They left evidence of their organization in places that archaeology has documented, and very likely in places that archaeology has not yet found, including, potentially, beneath the waters of the largest freshwater lake in the world. There is a particular location in the Lake Superior Basin, in waters near the Keweenaw Peninsula, that has been the subject of persistent interest among divers and independent researchers. The location is not publicized, partly out of concern that publicizing it would lead to disturbance of the site before it can be properly documented, and partly because the people who know about it have had enough experience with institutional indifference that they are not eager to hand over their hard-won information to an apparatus that may simply ignore it or worse, bury it. What the divers who have been to this location describe is a section of the lake floor where the stone formations are extensive, where the apparent regularity of the arrangement is difficult to attribute to any natural geological process they can identify, and where the preservation conditions, courtesy of the cold, dark water, are such that the stones appear almost as they would have when they were first placed. The cracks and surfaces of the individual stones are, in some cases, remarkably sharp. There is almost no biological growth on certain surfaces, which is unusual in lake environments, but consistent with the specific chemistry of Lake Superior water in this area. The researchers who have dived here speak about it with a combination of excitement and caution that is itself telling. They know what they are looking at, or they believe they know, but they also know that saying so too loudly, without institutional backing, will result in ridicule rather than investigation. And so the information circulates in a kind of underground among people who take it seriously, waiting for either the institutional courage to investigate properly or the accumulation of evidence so overwhelming that the mainstream can no longer pretend it is not there. The dating question is one of the most technically challenging aspects of this entire investigation. How old are the formations? This is the central question, and answering it properly requires methods and access that have not been fully brought to bear. The two most promising methods for establishing the age of underwater stone formations are absolute dating of organic material associated with the formations, if any organic material in datable condition can be found in association, and relative dating based on the lake level history, which is itself based on well-established geological evidence. The lake level approach is actually quite powerful in principle. If a formation can be shown to sit at the depth corresponding to the lake level at a specific period in the past, and if the formation appears to have been built on a surface that would have been dry land at that time, then you have a strong relative date. The challenge is that the lake level history of Lake Superior is complex and not perfectly understood for all periods, and that demonstrating a clear relationship between a specific formation and a specific historical lake level requires careful survey and analysis. None of this is impossible. All of it requires resources that have not been committed. The organic material approach faces the challenge that organic material associated with stone structures tends not to survive 10,000 years even in cold water, though there are exceptions and the preservation conditions in Lake Superior are better than most places. If charcoal or bone or other datable material were found in clear association with the formations, a radiocarbon date could establish the age of that material, and the relationship to the formations could provide a minimum age for the structures. This kind of investigation requires systematic excavation of sediment associated with the formations, which requires a research vessel, diving support, and methodical archaeological fieldwork. It has not been done. It needs to be done. The formations will wait. Lake Superior is patient. Beyond the stone formations, there is another category of evidence associated with Lake Superior that complicates the conventional picture even further. Petroglyphs, carved images in rock, are found throughout the Lake Superior region on both the Canadian and American sides of the lake. Some of these petroglyphs have been documented and studied. Many more are known to exist but have not been systematically catalogued. Some are in locations so remote, accessible only by water and only in calm conditions, that they are rarely visited and even more rarely studied. The images themselves range from the relatively recent and stylistically identifiable to the very old and in some cases genuinely strange. There are images that most researchers classify as consistent with known Anishinaabe and pre-Anishinaabe traditions, and there are images that resist easy classification. Images of figures and symbols that do not fit neatly into any known indigenous North American artistic tradition, but that also do not fit neatly into any known European tradition. Images that have been compared, by researchers willing to go out on a limb, to symbols from old world cultures with which no known contact occurred. The petroglyphs in the Agawa Rock area of the eastern shore of Lake Superior, which are among the most famous and best documented in the region, include images of a horned serpent figure, known in Anishinaabe tradition as Mishipeshu, images of canoes, and images of human figures whose interpretation has been debated for decades. These are accepted as genuinely ancient and culturally significant, but nearby, on rock faces accessible only by water, there are other images that have been photographed and that are less easily categorized, and whose age and cultural origin remain genuinely open questions. The entire visual record of the Lake Superior region, much of which remains uncatalogued and unstudied, represents a largely untapped archive of information about who was here and when and what they were thinking about. The underwater formations and the petroglyphs belong together in a comprehensive investigation of this region's pre-Columbian history. No such comprehensive investigation has been mounted. The relationship between what is found in the Lake Superior region and what is found in other parts of North America in the same general time period deserves more systematic attention than it has received. The old copper complex artifacts that have been recovered from burial sites and midden deposits across the Great Lakes region and beyond represent one of the most sophisticated metalworking traditions anywhere in the world at the time. The techniques used to work native copper, including cold hammering, annealing, and the production of complex composite tools, are not simple or obvious. They represent genuine technical sophistication that had to be developed over time. And the distribution of old copper artifacts across North America, with objects from Lake Superior copper appearing in archaeological sites hundreds and in some cases thousands of miles from the source, speaks to a trade and distribution network of considerable scale. The people who ran that network, who extracted the copper, processed it, traded it, and eventually, apparently, exported most of it somewhere beyond the boundaries of what we can currently trace, were not living in simple campsites by the lake shore. They had organizational structures, social hierarchies, logistical systems. They had places where they lived, where they worked, where they stored things, where they gathered for collective activities. The question is where those places were, and whether some of them are now underwater, preserved in the cold, dark depths of the lake that supplied their most important resource. The logic is straightforward. The evidence is suggestive. The investigation remains inadequate to the question. It would be wrong to pretend that all the questions about the Lake Superior formations point in only one direction, toward a conclusion that they are ancient human construction of great age and significance. The honest account of the evidence has to acknowledge the genuine uncertainties and the legitimate scientific arguments on the other side. Some geological formations in the Lake Superior Basin do produce surprisingly regular patterns. The basalt of the North Shore is prone to columnar jointing, a geological process that produces strikingly regular polygonal columns, sometimes resembling worked stone to an almost uncanny degree. The glacial history of the region has left behind a chaotic landscape of transported boulders, scraped and polished rock faces, and rearranged sediment in patterns that can look like deliberate arrangement. The human tendency to see pattern and intention in natural configurations is real and well documented. Researchers working in this area have to be genuinely careful not to fall into the trap of seeing what they want to see. The formations that are most likely to be genuinely significant are the ones where the combination of evidence is strongest, where the geological context does not support a natural explanation, where the pattern is too regular and too consistent to be attributed to chance, where the scale is large enough to require sustained human effort, where independent investigators examining the evidence without prior commitment have reached similar conclusions. The strongest cases from the Lake Superior evidence set do appear to meet these criteria, but the weaker cases, the formations that could go either way, should be held with appropriate tentativeness. The honest position is not that everything anomalous in this lake is necessarily ancient human construction, but that some of what is anomalous probably is, and that the question deserves serious investigation rather than reflexive dismissal. The story of the ancient copper miners of Lake Superior has a strange postscript that almost no one knows. When European fur traders and missionaries and eventually settlers began arriving in the Great Lakes region in the 17th and 18th centuries, They encountered the indigenous peoples of the region engaged in a relationship with the landscape that preserved, in attenuated form, memories of the earlier copper mining culture. The Anishinaabe people and their ancestors had knowledge of the copper deposits and used copper in their own material culture, though not at the industrial scale of the old copper complex people. They had stories about the ancient miners, though those stories were expressed in forms that European interpreters consistently misunderstood, treating as myth what may have been historical memory. When early European explorers began investigating the copper deposits of the Keweenaw Peninsula, they found evidence of ancient mining activity that astonished them. The ancient pits, the stone hammers, the sheer scale of previous extraction. They understood that something significant had happened here long ago, but they had no framework for understanding what it was. They assumed it must have been done by native peoples, which was correct in the broadest sense, but they lacked the archaeological tools to understand the age and scale and sophistication of what they were looking at. The first systematic archaeological investigations of the ancient copper mines came in the 19th century, and those investigations confirmed that the scale of extraction was truly extraordinary. But the question of where the extracted copper went, and who did the extracting at the height of the operation, was already becoming uncomfortable by the time serious researchers began asking it. And that discomfort has shaped the subsequent history of the question in ways that continue to prevent clear answers. Something about the underwater world of Lake Superior exerts a particular pull on the human imagination, and this pull is not entirely irrational. There is something genuinely mysterious about a body of water large enough to have its own weather, deep enough to be beyond the reach of light, cold enough to preserve what falls to its floor for thousands of years. The old Great Lakes mariners had a saying that the lake never gives up its dead, referring to the fact that the cold water prevents the bacterial decomposition that causes bodies to float to the surface in warmer environments. Bodies that sink in Lake Superior stay sunk. Ships that go down in Lake Superior stay down, largely intact, because the cold and the depth and the limited biological activity in the deep water mean that the normal agents of decay work much more slowly. This is the quality that makes the lake such a remarkable archaeological archive. It is also the quality that gives the lake its aura of the uncanny. Things that disappear into Lake Superior are not destroyed. They are preserved. They are waiting. And the thought that among the things waiting in that cold, dark water are structures built by people who understood something about this landscape that we have forgotten entirely, that thought is difficult to set aside once it has taken hold. The question of what Lake Superior looked like 12,000 years ago, when the last glaciers were retreating and the lake was first forming in something approaching its current configuration, is one that geologists can address with reasonable confidence. The retreat of the Laurentide ice sheet from the Lake Superior basin was not a simple event. It was a complex, multi-stage process that took thousands of years and involved repeated advances and retreats of the ice margin, changing outlets for the meltwater, and dramatic fluctuations in lake level. In the earliest stages, what is now Lake Superior was a series of glacial lakes with different configurations than the modern lake. The water was in some places much higher than today, draining through outlets to the east. In other periods, the water was much lower, exposing large areas of what is now the lake floor as dry land. The geological evidence for these ancient shorelines is preserved in features like beach ridges and wave-cut terraces that can be found at various elevations around the lake basin. The ancient beaches, the places where people would have lived if they were here, are distributed across a range of elevations from well above the current lake surface to well below it. If people were living around this lake during the period of shifting water levels, and there is now good evidence that they were, their habitation sites would be found at multiple different depths, some exposed on land and some now underwater. The underwater sites, by definition, are the ones that have been least studied and that potentially preserve the most information, precisely because underwater burial has protected them from the erosion and agricultural disturbance and casual destruction that has affected the above-water archaeological record over the past 10,000 years. The intersection of marine archaeology, Great Lakes geology, and the broader questions of pre-Columbian North American history represents one of the most genuinely exciting and genuinely underfunded frontiers in current archaeological research. Technology has made underwater archaeology more accessible than ever before. Side-scan sonar can map the lake floor in detail without sending divers into dangerous conditions. Remotely operated vehicles can photograph and even sample formations at depths that are beyond human diving range. Environmental DNA techniques can potentially extract biological and even cultural information from sediment samples without disturbing the physical record. GPS and GIS mapping tools can produce precise three-dimensional models of formations for analysis by specialists who never need to get wet. All of these tools are available. They are being used in other parts of the world on questions that the archaeological mainstream has decided are worth investigating. They have not been systematically deployed in the depths of Lake Superior. The barriers are not technical. They are institutional and financial, and, at bottom, philosophical. You have to believe that something is there before you will invest in the technology to look for it. And believing that something is there requires a willingness to take seriously the possibility that the standard history of pre-Columbian North America is significantly incomplete. That willingness is slowly growing. The evidence keeps accumulating. The question keeps pressing. And the lake keeps holding its silence, cold and deep and full of whatever it contains. The concept of a pre-Columbian civilization sophisticated enough to build stone structures on the shores of Lake Superior, to mine copper on an industrial scale, and to distribute that copper across a continental trade network is not as radical as it might sound to someone whose only exposure to the subject is a standard school history curriculum. The professional archaeological literature, whatever its limitations and blind spots, already documents pre-Columbian cultures in North America with levels of social complexity, technological sophistication, and organizational capacity that would allow for exactly this kind of activity. Poverty Point was building large-scale earthworks more than 3,000 years ago. Cahokia was running an urban center comparable to contemporary European cities 1,000 years ago. The Mississippian culture was maintaining complex political and economic networks across half the continent. These are established facts. They are in the textbooks, though not always prominently. What is not yet in the textbooks, because it has not yet been properly investigated, is the potential that the Great Lakes copper culture of 5,000 to 10,000 years ago was operating at a comparable level of social complexity, and that it left physical evidence of that complexity in the form of structures that now sit at the bottom of Lake Superior. The gap between what the evidence suggests and what the mainstream accepts is closing. It closes slowly, reluctantly, one piece of documentation at a time, but it is closing. There is a specific detail about the old copper complex that almost never appears in popular accounts, but that changes the picture considerably. Analysis of the copper artifacts from this tradition reveals that the metalworkers who made them understood the principles of work hardening and annealing at a level of practical sophistication that goes well beyond what you would expect. From casual experimentation, copper, when worked cold, becomes progressively harder and more brittle through a process called work hardening. If you continue to work it without relieving the internal stress, it will eventually crack. The solution, developed independently in multiple metalworking traditions around the world, is to periodically heat the copper to a specific temperature and allow it to cool slowly, a process called annealing that relieves the internal stress and restores the metal's workability. The old copper complex artisans did this. They understood the property, they applied it systematically. The artifacts they produced show evidence of careful cyclic cold working and annealing that produced objects with consistent material properties. This is not accidental knowledge. It is the product of careful observation, deliberate experimentation, and systematic application over a long period of time. It represents a level of empirical investigation, what we would now call material science, that the standard framework for Stone Age North America does not easily accommodate. If the metalworkers of the old copper complex were doing material science, what else were they doing? What else did they know? What other aspects of their material and intellectual culture are we missing because the evidence is underwater or undiscovered or classified under categories that prevent us from recognizing it for what it is? It is worth pausing here to consider what a genuine investigation of the Lake Superior underwater formations would actually look like, because imagining it in concrete terms helps to make clear both how feasible it is and how little progress has been made toward it. A serious investigation would begin with a comprehensive sonar survey of the entire lake floor, with particular attention to the areas where divers and researchers have already reported anomalous formations, and to the areas corresponding to the ancient shoreline levels established by geological research. This survey would produce a detailed map of the lake floor topography and allow researchers to identify and prioritize specific sites for closer investigation. The cost of such a survey is substantial, but not prohibitive. It is comparable to the cost of a single season of field excavation at a mid-sized terrestrial archaeological site. Following the survey, Targeted investigation of the highest priority sites would involve ROV photography and sampling, analysis of sediment samples for environmental DNA and datable organic material, and detailed three-dimensional scanning of apparent structural features. Again, the technology exists, the expertise exists, and the cost, while significant, is not beyond the range of a well-funded research project. What is missing is not technology or expertise or even money in any absolute sense. What is missing is institutional will. Someone has to decide this is worth doing. That decision requires a shift in the mainstream assessment of what is likely to be found. And that shift is happening, slowly, driven by the accumulation of evidence and the persistence of the researchers who refuse to accept that the standard framework is the last word on the subject. The history of North American archaeology is full of moments where the accepted picture was dramatically revised by evidence that was initially dismissed or ignored. The discovery of Poverty Point in the 1950s required archaeologists to substantially revise their picture of pre-Columbian social complexity in the lower Mississippi Valley. The discovery and eventual acceptance of Monteverde in Chile required a complete revision of the Clovis First model. The documentation of pre-Columbian agriculture and land management by indigenous peoples across North America required a revision of the image of hunter-gatherers as passive inhabitants of a wilderness they found but did not shape. Each of these revisions was resisted. Each was eventually accepted because the evidence was simply too strong to deny. The Lake Superior formations represent the next potential revision. They will probably not be the last. The history of this discipline suggests that the standard framework is always a work in progress, always being pushed and prodded by evidence that does not fit, always eventually catching up to the reality that the earth beneath us and the water above it contains more history than the textbooks acknowledge. The specific revision that the Lake Superior evidence points toward is the recognition that complex, organized cultures were operating in the Great Lakes region much earlier than the current framework allows, that those cultures left physical evidence of their complexity that has been partially preserved underwater, and that properly understanding North American prehistory requires taking that evidence seriously. This is not a radical claim. It is a conservative claim, in the sense that it follows directly from the existing evidence rather than leaping beyond it. The radical claim would be to assert that the formations are of known age and known cultural origin. The conservative claim is simply that they deserve to be investigated. That claim has not yet been adequately honored. The light does not reach the bottom of Lake Superior, not even in the clearest water on the brightest day. The depths of this lake are as dark as any place on the surface of the earth. In that darkness, in that cold, in that silence that is broken only by the occasional slow movement of the thermocline and the even slower settling of sediment, whatever is down there sits and waits. It has been waiting for a long time. The stone formations, if they are what the researchers who have seen them believe them to be, have been waiting in the dark for perhaps 10,000 years. Perhaps more. They have waited through the rise and fall of every civilization that history records, through the Bronze Age and the Iron Age, and the Age of Sail and the Industrial Revolution and the Digital Revolution, through every war and empire and dynasty and collapse, through everything that we call history. They have been sitting in the cold, dark water at the bottom of the largest freshwater lake in the world, undisturbed, unexamined, holding their silence. What they would tell us, if we gave them the serious scientific attention they have not yet received, is something we genuinely cannot know in advance. That is the nature of evidence. It tells you what it tells you, not what you expect or hope. The formations might turn out to be natural. They might turn out to be human-made structures from a cultural tradition we already know, that arrived in the region later than the geological evidence suggests. They might turn out to be evidence of a pre-Columbian culture so early and so sophisticated that it reshapes everything we think we know about the deep history of North America. The only way to find out is to look, not to glance, not to dismiss, not to file under, requires further study and move on. To look seriously, with the full toolkit of modern science, with institutional commitment, with the willingness to accept whatever the evidence shows. Lake Superior has been holding this mystery for a very long time. It will go on holding it until someone decides that the answer is worth more than the comfort of not having to revise the textbooks. There are researchers today, working quietly, often without institutional support, who have dedicated significant portions of their professional lives to understanding the pre-Columbian history of the Great Lakes region. They publish in small journals. They present at conferences that the mainstream does not attend. They dive in cold, dark water on their own time and their own money and document what they find as carefully as their limited resources allow. They collaborate with indigenous knowledge keepers who bring to the conversation a depth of connection to this landscape and this history that no amount of academic training can replicate. They build the case piece by piece, documentation by documentation, dive by dive. They know the standard objections and they have thought carefully about them. They know where their evidence is strong and where it is still circumstantial. They are doing real work on a real question, and they deserve recognition and support rather than dismissal. The community of researchers genuinely engaged with the Lake Superior question is not large, but it is serious, it is growing, and it is producing documentation that will eventually be impossible to set aside. The momentum is slow, but it is real. The lake does not change. The formations do not move. The evidence accumulates. When you stand on the shore of Lake Superior on a calm day, the water is so clear near shore that you can see the bottom at 10 or 15 feet as if through glass. The stones on the shallow lake floor are visible in astonishing detail, their colours bright in the filtered light, their surfaces clear. You can see the individual pebbles, the smooth glacial cobbles, the occasional larger boulder sitting exactly where the receding ice left it 12,000 years ago. It looks like the world has been arranged for your inspection. But the deeper water, just a few hundred feet out, is already dark. The light dies at the thermocline. The colour bleeds out of the water, and beyond that boundary lies everything that is too deep for the light to reach, and too deep for the eye to see, and too deep for the casual curiosity of people standing on the shore. What lies in that deep dark water is the real question. The shore is the margin, the depths are the archive. And the archive has not yet been properly read. The stones arranged in patterns that do not match the geological record, the alignments that track astronomical events, the tool marks on surfaces that should bear no tool marks, the right angles in places where geology does not produce right angles, all of it sitting in the cold dark water, patient, preserved, waiting. The largest freshwater lake in the world is keeping a secret, and the secret is old enough and significant enough that it belongs in the conversation about who we are as a species and how long we have been here, and what we were capable of long before the history books say we were capable of anything at all. That conversation is beginning, slowly, imperfectly, without the institutional support it deserves. But it is beginning, and Lake Superior, cold and deep and old beyond reckoning, is at its centre. The underwater ruins of Lake Superior are not simply an archaeological curiosity, they are a test. A test of whether science as an institution is capable of updating its models in the face of uncomfortable evidence, of whether the mechanisms designed to separate reliable knowledge from comfortable fiction are actually working, of whether the history we tell ourselves about this continent is honest. The formations in the cold water ask a simple question, and they have been asking it for a very long time. Who were we? Who was here before the history books say anyone was here? What did they build? Where did it go? The lake holds the answer, or part of it, and the answer, whatever it turns out to be, matters. It matters because understanding the full depth of human presence in North America changes the story we tell about human capability and human history. It matters because the cultures that lived here, that mined this copper, that built in this landscape, that developed the knowledge systems that allowed their descendants to survive and flourish for millennia, were real people with real achievements, and those achievements deserve to be known. It matters because the descendants of those people are still here, and their traditions and their knowledge and their oral histories carry information that the archaeological record has not yet fully confirmed, but that the accumulating evidence increasingly supports. The ruins beneath Lake Superior are waiting. The question is whether we are willing to go looking in a way that takes seriously what we might find. There is one more thing worth saying about this mystery before we let the lake have the last word. The formations beneath the water, the copper mines on the shore, the petroglyphs on the rock faces, the oral traditions of the peoples who have lived here since before memory becomes history, all of these things together constitute a picture of the pre-Columbian Great Lakes region that is richer, stranger, deeper, and more impressive than anything the standard textbook version contains. This region was not a peripheral wilderness waiting to be discovered. It was a center. It was a place where something significant happened, over a very long time, on a scale that we are only beginning to appreciate. The copper of Lake Superior may have fueled the Bronze Age on the other side of the world. The social and technological innovations of the Great Lakes cultures may have shaped developments across the entire continent. The knowledge systems developed here, the understanding of this landscape and its resources and its dangers, represent intellectual achievements of the highest order. And beneath the surface of the largest freshwater lake in the world, in cold, dark water that preserves what falls to it with almost geological fidelity, there is evidence of that history. Not all of it, not even most of it, but enough. Enough to ask the question seriously, enough to demand the investigation. Enough to insist that the story of North America does not begin 13,000 years ago or 500 years ago, but goes back much, much further, into a depth of time that the standard framework is only now beginning to acknowledge. The lake is waiting. The stones are waiting. The question is waiting. And somewhere in the depths of Lake Superior, in the cold and the dark and the silence, the answer waits with them. If this journey into the deep past of Lake Superior has left you with more questions than it answered, that is exactly as it should be. The greatest mysteries are not the ones with easy solutions. They are the ones that, the more carefully you examine them, the more they open out into larger and stranger territories than you expected when you started. The formations beneath Lake Superior open out into questions about the entire pre-Columbian history of North America, into questions about the capabilities of cultures that have been systematically underestimated for generations, into questions about how science works and what evidence gets taken seriously and why. These are not comfortable questions, but they are important ones, and they belong to everyone who is willing to ask them. If you have found this story compelling, if you want to keep exploring these quiet corners of history and prehistory and the deep human past, you can tap like so the algorithm knows to show you more. Leave a comment if you would like. Tell us where in the world you are lying in the dark listening to this. What landscape is outside your window tonight? What body of water is nearest to you? What ancient ground you are sleeping above? The lake has been keeping this secret for 10,000 years. It can wait a little longer for the rest of the world to catch up. For now, let the cold, dark water and the waiting stones carry you gently towards sleep, and know that somewhere beneath the largest lake in the world, in the silence and the darkness and the cold, something that was built by human hands a very long time ago is still there, patient and preserved, and full of everything we have not yet had the courage to find out. Let us go deeper, because the surface of this story, the one about stone formations and copper mines and underwater ruins, is only the beginning. Beneath it lies a much larger and more troubling question about what we actually know about the history of this continent, how we know it, and what we have been doing with the parts that do not fit. The Lake Superior mystery is not an isolated oddity. It is one data point in a pattern that stretches from the southern tip of South America to the Arctic, from the Atlantic coast to the Pacific, and that suggests something fundamentally different from what the standard historical framework has been telling us. The pattern is this. The pre-Columbian peoples of the Americas were doing things far earlier, far more extensively, and far more impressively than the history books have ever properly acknowledged. Not in a fringe, conspiratorial sense, in a documented, peer-reviewed archaeological record sense. The challenge is that the documentation is scattered across dozens of disciplines and hundreds of publications and thousands of site reports, and no one has pulled it together into a coherent narrative that makes the full picture clear. So instead we have a mainstream that clings to an increasingly inadequate framework while the evidence quietly accumulates in the margins, and we have an alternative literature that overreaches, that mixes genuine anomalies with speculation and wishful thinking until the signal is buried in noise. The Lake Superior formations sit in this contested territory. They are real. The questions they raise are real. And navigating toward honest answers requires acknowledging both the genuine evidence and the genuine uncertainty, without collapsing into either institutional denial or uncritical credulity. The idea of ancient maritime contact across the Atlantic is one that the mainstream has resisted with extraordinary tenacity, and the resistance has not always been purely scientific. There are careers invested in the Clovis First model and its successors. There are textbooks written, curricula designed, funding structures built around specific assumptions about when people arrived in the Americas and from where. Challenging those assumptions is not merely an intellectual exercise. It has professional consequences for the people involved. This is not a conspiracy. It is a structural feature of how academic disciplines work. Paradigms change slowly because individuals resist change, and individuals resist change in part because change is professionally costly. Thomas Kuhn described this pattern in his analysis of scientific revolutions, and it applies with particular force in a field like pre-Columbian archaeology, where the political and cultural stakes are high alongside the professional ones. The indigenous peoples of the Americas have legitimate and important concerns about how their history is told and by whom, and those concerns have sometimes been used by mainstream institutions as a reason to avoid investigating questions that might produce uncomfortable answers, which is both epistemically wrong and ultimately disrespectful to the indigenous peoples whose interests are being nominally protected. The real respect is to investigate honestly, with indigenous participation and consent, and to follow the evidence wherever it leads. The Lake Superior formations deserve that investigation. The question of ancient contact deserves that investigation. The alternative, willful ignorance dressed up as sensitivity, serves no one. Consider for a moment the specific geography of the Keweenaw Peninsula and what it would have looked like to someone arriving from across the Atlantic in the period of the Old Copper Complex, roughly 5,000 to 10,000 years ago. Coming from the north, following the coast of Labrador and then the southern shore of what is now the Canadian Shield, you would eventually arrive at the eastern end of Lake Superior. The lake is large enough that navigating it requires genuine maritime skill. The storms can be violent enough to swamp anything less than a well-built, well-handled vessel. But the resources along its shore, and particularly at its southwestern end where the copper deposits are concentrated, are extraordinary. Native copper lying in the rock, accessible without smelting, in quantities so vast that even intensive extraction over thousands of years barely made a dent in the total deposit. For a Bronze Age maritime culture that needed copper desperately, that was building an economy and a military capacity around the metal, the discovery of such a deposit would not have been forgotten. It would have been the most important geographical fact in the world. It would have generated return voyages. And if return voyages happened, repeatedly, over centuries, the people making those voyages would have left traces. They would have built places to stay. They would have interacted with the local populations. They would have created a material culture in this region that would not look exactly like the indigenous cultures of the Great Lakes, and would not look exactly like the cultures of the Old World, but would show influences from both. The question is whether the archaeological record contains those traces, and whether the formations beneath the lake are among them. The ancient shoreline of Lake Superior, as it existed during the most intensive period of copper extraction, would have been a remarkable landscape. The copper deposits of the Keweenaw Peninsula were accessible from the shore. The forest was dense but not impenetrable. The lake itself, though capable of violence, offered a highway connecting the extraction sites to whatever trade network the copper was entering. The people who worked the mines would have had a base camp, a headquarters, a place from which the operation was organized and to which the processed copper was brought before being shipped out. That base camp, wherever it was, would have been substantial. Not a temporary campsite, but a semi-permanent installation supporting a large-scale industrial operation over an extended period. It would have had storage facilities, processing areas, living quarters, and possibly ceremonial spaces, of the kind that complex societies invariably build. The question is where this base camp was, and whether it is now underwater. The geological evidence for lake level change in the region of the Keweenaw Peninsula during the relevant time period suggests that the most logical locations for a large base camp of this period are now submerged. The ancient beach lines that correspond to the water levels of 5,000 to 10,000 years ago are underwater. The flat, accessible, well-positioned areas near the copper deposits that would have made the best sites for a large, organized community are the areas that were later flooded as the lake level rose. If the base camp of the old copper complex operation is anywhere, it is likely in that submerged zone. And if it is there, it would represent one of the most significant archaeological sites in North American history. The silence around this question is not total. There are researchers who have published serious work on the Lake Superior copper trade and its potential connections to Old World Bronze Age cultures. The work of S.A. Sherrod and others in the 1990s and early 2000s raised these questions with genuine scholarly rigor and documented some of the evidence for the scale of the copper extraction and its potential distribution. The work of scholars studying the population genetics of indigenous American peoples has increasingly revealed patterns of ancient contact and migration that do not fit the simple Beringia model. The work of underwater archaeologists in other parts of the world, particularly in the Mediterranean and Scandinavia, has demonstrated what is possible when the discipline commits seriously to investigating submerged sites. All of this work has been quietly, steadily building a case for taking the Lake Superior question seriously. It has not yet generated the institutional response that would allow for the kind of comprehensive investigation the question deserves. But the intellectual foundation is being laid, piece by piece, publication by publication, dive by dive. The Lake Superior formations sit at the center of a convergence of evidence from multiple disciplines, and that convergence is becoming difficult to ignore. The people who actually mined the copper of the Kiwi Nor and Isle Royale were, by any reasonable assessment, extraordinary. They operated in conditions that would challenge a modern industrial operation. The northern shore of Lake Superior in winter is genuinely brutal. Temperatures routinely drop to 30 and 40 below. The lake generates its own weather, with wind chills and lake-effect snow that can make conditions suddenly and dangerously severe. The rock of the Kiwi Nor is hard, difficult to work, and not uniformly distributed with the copper-bearing veins that make the extraction worthwhile. Identifying the most productive areas, developing the tools and techniques to extract the copper efficiently, organizing the labor of what must have been a substantial workforce, managing the logistics of feeding and sheltering that workforce in a remote location over an extended season, and then transporting thousands of pounds of processed copper out of the region, along whatever route connected the mines to the broader trade network. All of this required a level of organizational and technological sophistication that the standard image of Stone Age North America does not comfortably accommodate. And yet it happened. The evidence is incontrovertible. The copper was extracted. The stone hammers are there, the pits are there. The processed copper shows up in archaeological sites across the continent. The question is not whether the old copper complex people were capable of extraordinary organizational and technological achievement. The question is what else they achieved that we have not yet found or not yet recognized. There is a category of evidence that is rarely discussed in public accounts of the Lake Superior mystery, but that is quietly significant to researchers who know what they are looking at. This is the category of unprovenanced copper artifacts, objects made from Lake Superior native copper that have been found in contexts that do not fit the expected distribution pattern of old copper complex trade. These are objects that have turned up in places and in associations that suggest they traveled routes that the standard trade network model does not account for. Some researchers have pointed to the similarity between certain types of Lake Superior copper artifacts and artifact types found in Bronze Age contexts in Europe and the Near East. The similarities are not identical. They are the kind of functional and formal parallels that could result from independent invention by cultures working with similar materials under similar constraints, or they could result from contact and diffusion. Distinguishing between these two explanations requires the kind of detailed comparative analysis and chemical provenance testing that has not been systematically applied to the relevant collections. But the parallels are there, and they have been noted by serious researchers, and they are consistent with the broader hypothesis of transatlantic copper trade that the disappearance of the extracted copper already points toward. The chemistry of native copper is potentially one of the most powerful tools available for addressing the question of transatlantic copper trade. Because different copper deposits have different chemical signatures, the ratios of trace elements in native copper vary from deposit to deposit in ways that are characteristic and measurable. If the copper in Bronze Age European and Near Eastern artifacts could be shown to match the chemical signature of Lake Superior native copper, that would be extraordinarily powerful evidence of contact. Some work along these lines has been attempted. The results have been suggestive but not conclusive, partly because the analytical techniques available in the earlier decades of this research were not precise enough to make definitive attributions, and partly because the political and professional sensitivity of the question has made it difficult to get the access to collections and the funding for analysis that a definitive study would require. Modern analytical techniques, particularly lead isotope analysis and trace element profiling using inductively coupled plasma mass spectrometry, are precise enough to make much more confident attributions than were possible even 20 years ago. A systematic study of Bronze Age copper artifacts using these techniques, comparing them to the known chemical signatures of Lake Superior native copper and other potential source deposits, would potentially resolve the question of the Atlantic copper trade decisively. That study has not been done, or if it has been done, the results have not been published in a form that has reached the mainstream discussion. The failure to conduct or publish this research is itself a kind of data, though not the most useful kind. The oral traditions of the Anishinaabe and related peoples contain descriptions of a culture hero called Nanabozho, or in some versions Winnebago or Manabozho, whose stories include accounts of transforming the landscape, creating features of the natural world, and interacting with the forces that govern the relationship between human beings and the living world around them. These stories have been treated by Western interpreters almost exclusively as myth, as cosmological narrative with no historical referent. But comparative mythologists and researchers in the emerging field of geomythology have increasingly recognized that traditions of this type often encode real historical or geological events in narrative form. The stories of Nanabojo include episodes that some researchers have connected to the geological upheavals associated with the end of the last ice age, to the catastrophic floods that would have resulted from the draining and refilling of glacial lakes, and to the transformation of the landscape that occurred as the glaciers retreated and the Great Lakes took their current form. If these traditions carry genuine historical memory, they push the period of Anishinaabe presence in the Great Lakes region back much further than the standard archaeological timeline allows. And if the people who developed these traditions were present in the region during the period when the landscape was being transformed by the retreat of the glaciers, they were witnesses to events that occurred 12,000 years ago or more. The implications for the archaeological record of who was here and when are significant. The island of Isle Royale, which sits in the northwestern arm of Lake Superior closer to the Canadian shore than the Michigan shore, has a special significance in the story of the ancient copper mines. The island is largely wilderness today, a national park accessible only by ferry or seaplane, with no permanent residents and no roads. But it sits on top of copper deposits that were mined intensively in ancient times, and the evidence of that mining is extensive and well documented. Hundreds of ancient pits, thousands of stone hammers, evidence of systematic, organized extraction over a long period of time. The island itself is remote enough that maintaining a mining operation there would have required genuine maritime capability. You could not walk to Isle Royale. You had to cross open water. In summer conditions, the crossing is manageable in a well-made canoe. In the conditions that sometimes prevail in Lake Superior, it is seriously dangerous in anything less than a substantial vessel. The people who mined Isle Royale were not accidental visitors who stumbled upon the copper while fishing. They made a deliberate decision to cross open water to a specific island because they knew the copper was there, and they organized a sustained operation to extract it. That level of intentionality, that degree of specific geographical knowledge applied to a specific economic purpose, is exactly what you would expect from a culture with the social complexity and organizational capacity to build permanent structures on the lakeshore. The copper mines and the underwater formations belong together in the same story. The number 500,000 to £1.5 billion is worth dwelling on for a moment, because it is easy to let a number that large pass through the mind without really settling. Imagine £1 billion of copper. That is 500,000 tons. 160,000 average-sized cars weigh roughly £1 billion. If you stacked the copper extracted from the Lake Superior mines in the form of the ore-sized chunks that would have been processed on site, the pile would be visible from a considerable distance. And this copper was moved by hand, in stone containers, animal hide bags, wooden crates, whatever containers were available, over distances that, depending on where it ultimately went, range from hundreds to potentially thousands of miles. The logistics of this operation are staggering. They require planning and organization at a scale that implies genuine social hierarchy, genuine institutional structure, genuine long-term economic planning. The people who ran this operation were not making individual decisions about individual pieces of copper. They were managing a system, and systems require infrastructure. They require places to coordinate, to store, to process, to plan. They require permanent or semi-permanent installations at key nodes of the network. The Lake Superior underwater formations may be the remains of exactly these nodes, the places where the system was physically anchored to the landscape. There is a phenomenon in the study of ancient sites that archaeologists call negative evidence, and it is one of the most epistemically treacherous concepts in the discipline. Negative evidence is the absence of finds in a location where you are looking for finds. In theory, the absence of evidence for human activity in a given location after a thorough investigation can be taken as evidence that no human activity occurred there. But the qualification is critical. After a thorough investigation, if the investigation was not thorough, if it was conducted in the wrong places at the wrong depths using the wrong methods, then the absence of finds tells you nothing about whether activity occurred. It tells you only that the investigation did not find it, which is a very different statement. The Lake Superior formations and the broader question of pre-Columbian activity in the region have not been thoroughly investigated. The relevant depths of the lake have not been systematically surveyed. The geological context of potential sites has not been fully modeled. The methodological toolkit that could address these questions has not been deployed. In this situation, the absence of a smoking gun discovery that the mainstream cannot deny is not evidence that nothing is there. It is evidence that the investigation has not been adequate to the question, and insisting on treating inadequate negative evidence as definitive negative evidence is a methodological error of the first order. The night sky above Lake Superior, on a clear night far from city lights, is one of the most remarkable sights in the Northern Hemisphere. The Milky Way is visible as a solid band of light. The stars are brilliant and numerous and arranged in patterns that human beings have been tracing and naming for longer than recorded history. The cultures that lived around this lake in the ancient past looked at this same sky, and they looked at it with a purpose that went beyond simple wonder. They used it. They read it for information about the seasons, about the movements of animals, about the timing of agricultural or extractive activities, about the passage of time on scales longer than a single human life. The astronomical knowledge encoded in the oral traditions and material culture of the Great Lakes region is considerable, though it has not been systematically studied with the tools of modern archaeoastronomy. There are alignments in some of the stone formations found above the waterline in the Lake Superior region that appear to correspond to significant astronomical events, the solstices, the equinoxes, the rising and setting of specific stars at specific times of year. Whether these alignments are intentional or coincidental requires careful statistical analysis and contextual interpretation. Some researchers who have looked at them seriously have concluded that they are intentional. Others remain unconvinced. The question has not been settled because the systematic investigation that would settle it has not been conducted. But the possibility that some of the Lake Superior formations, both above and below the waterline, functioned as astronomical markers is consistent with what is known about the astronomical sophistication of pre-Columbian cultures across North America, and it adds another dimension to the mystery. The relationship between the formations beneath Lake Superior and the broader network of ancient sites across the Great Lakes region is something that researchers are only beginning to map with any precision. The Great Lakes region contains an extraordinary concentration of ancient earthworks, burial mounds, stone circles, and other features that represent the visible portion of a landscape that was intensively modified by human activity over thousands of years. The mound builders of Ohio and the broader Midwest are among the best-known pre-Columbian builders in North America, with earthworks that in some cases rival the scale of Old World monuments. The Serpent Mound in Ohio, a quarter-mile-long effigy of a serpent built on a geological feature associated with an ancient meteor impact, is one of the most dramatic ancient monuments in the world. The Newark earthworks, a complex of geometric earthworks covering 4 square miles in Ohio, represents a scale of landscape modification that required thousands of workers and centuries of sustained effort. These are not isolated sites. They are part of a regional pattern of organized, large-scale construction that stretched across the entire Great Lakes and Ohio Valley region, and that connected, through trade networks and cultural influence, to cultures across the continent. The underwater formations of Lake Superior sit at the northern edge of this pattern. They are the piece that is missing from the picture, the northern anchor of a network that the visible archaeological record only partially reveals. When the full picture is assembled, it will show something considerably more impressive than what the current understanding of pre-Columbian North America acknowledges. The wood that was used in ancient Great Lakes construction has almost entirely decomposed. This is one of the most significant losses in the archaeological record of the region. Wood was the primary construction material for most of the cultures that lived here. Wooden posts, wooden platforms, wooden structures of all kinds. In the terrestrial archaeological record, wood rarely survives more than a few centuries in the temperate, biologically active environment of the Great Lakes region. But in the cold, anaerobic environment of Lake Superior's depths, wood can survive for a very long time. There have been cases of ancient wood recovered from deep freshwater environments in excellent condition. If wooden structural elements are associated with the stone formations on the lake floor, and if they have been preserved by the cold water, they could provide both datable material for radiocarbon dating and physical evidence of the construction techniques used by the people who built the structures. The possibility of finding preserved wood in association with the formations is one of the most compelling arguments for conducting a systematic underwater investigation. The cold, dark, low-oxygen environment of the deep lake has served as an inadvertent preservation facility for potentially thousands of years. What it has preserved, beyond the stone formations themselves, is unknowable until someone goes to look. There are accounts, some documented and some purely anecdotal, of objects being found in and around Lake Superior that do not fit the expected archaeological profile of the region. Tools made from materials not native to North America. Artifacts with formal characteristics that do not correspond to any known indigenous North American tradition. Stones with markings that resemble scripts or symbols from Old World cultures. Most of these accounts are difficult to verify because the objects in question are not in institutional collections, are not available for expert analysis, and are known only from descriptions passed through multiple hands. The epistemological value of such accounts is limited, but they are consistent with a pattern that appears elsewhere in pre-Columbian contact research. The occasional surfacing of objects that do not fit the expected picture, often in circumstances that make systematic study difficult, and often followed by institutional dismissal that does not engage with the specific evidence. The Lake Superior region is large. Much of its shoreline is remote and largely uninhabited. The number of people who have spent serious time in remote areas of this shoreline and have found things they could not explain is probably not small. The number of those people who have reported what they found to institutions that took it seriously is almost certainly very small. The gap between what has been found in this region and what has been formally reported and studied is, by any reasonable estimate, enormous. This is not a peculiarity of the Lake Superior case. It is a pervasive feature of archaeological discovery in North America, where a significant fraction of significant finds are made by non-professionals and never enter the institutional record. The concept of living archaeology, the idea that oral tradition and cultural practice carry information about the ancient past that can supplement and sometimes correct the purely material archaeological record, is gaining increasing acceptance in the mainstream of the discipline. This is partly a result of better methodological tools for evaluating oral traditions and partly a result of political and ethical pressures to take indigenous knowledge seriously as a form of evidence. In the Lake Superior context, living archaeology takes the form of the oral traditions of the Anishinaabe and related peoples, which contain information about places, events, and practices that predate European contact by an unknown but substantial amount of time. These traditions have been the subject of serious scholarly attention by researchers like Basil Johnston and Edward Benton Banai, and many others who have worked to document and interpret them with both academic rigor and cultural respect. The traditions describe a world that in some ways matches the emerging archaeological picture of the ancient Great Lakes region, and in some ways goes further than the archaeological record has yet confirmed. They describe large-scale movements of people. They describe significant transformations of the landscape. They describe encounters with beings and forces that Western interpreters classify as supernatural, but that indigenous interpreters understand as descriptions of actual historical and natural phenomena in the cultural vocabulary, appropriate to the tradition. Taking these traditions seriously as historical evidence, alongside the material archaeological evidence, creates a much richer and more complex picture of the ancient Great Lakes region than either source provides on its own. The geology of the Keweenaw Peninsula is, in itself, one of the most extraordinary geological stories on the North American continent, and understanding it properly puts the copper mining question in a context that makes the scale of the ancient operation more comprehensible. The copper deposits of the Keweenaw are the result of a billion-year-old geological event called the Mid-Continent Rift, in which the North American continent actually began to split apart, much as the East African Rift Valley is splitting Africa today. The rift failed, and the continent stayed in one piece, but the volcanic activity associated with the attempted rift produced massive basalt flows that carried copper in solution and deposited it in veins and masses as the lava cooled. The result is one of the largest and most accessible native copper deposits in the world, sitting in rock that was then buried under ancient seas, uplifted, eroded, and finally exposed by glacial activity over the last few 100,000 years. The glaciers that carved the Lake Superior Basin also scraped and deposited copper-bearing rock across a wide area, which is why copper shows up not only in the bedrock of the Keweenaw but in glacial deposits across the Great Lakes region. The ancient miners who discovered this deposit discovered it in a geological context that made it unusually accessible. They did not need to smelt ore. They did not need furnaces or metallurgical technology. They needed to identify productive areas, remove overburden, break up the copper-bearing rock, and extract the copper masses. The technology required for this, though labor-intensive, was within the capability of any sufficiently organized group of people with access to hard stone for tools and fire for heating rock to make it more brittle. The sophistication was organizational and logistical, not technological in the metallurgical sense. And it was that organizational and logistical sophistication that would have generated the kind of permanent infrastructure, the settlements and storage facilities and ceremonial spaces whose remains may be sitting on the lake floor. One of the more striking details about the ancient copper mines is the evidence of seasonal use. Analysis of the archaeological deposits in the mining pits and surrounding areas suggests that the mines were worked primarily during the summer months, when the lake was navigable and the extraction work could be conducted without the extreme cold of the northern Michigan winter making conditions unworkable. This seasonal pattern implies that the miners arrived at the beginning of the working season and departed at the end of it, returning to a home base that may have been elsewhere in the Great Lakes region or potentially further away. But seasonal workers need to leave their equipment and processed copper somewhere between seasons. They need facilities for storing and securing the products of their labor between the end of one working season and the beginning of the next. And if the operation was large enough and continuous enough, eventually some workers would winter over, maintaining the facilities and preparing for the next season's work. These considerations point toward the existence of a more or less permanent facility in the region of the mines, a facility substantial enough to support significant numbers of people, to store considerable quantities of processed copper, and to serve as the organizational hub for the entire extraction operation. The most logical location for such a facility would have been on the shore of the lake, accessible by water, close to the extraction sites, and positioned to facilitate the shipment of copper out of the region at the beginning and end of each working season. And the shore of the lake in the period of most intensive mining is now, in significant portions, underwater. What does it mean to have a billion-year-old copper deposit at the edge of a lake that formed 12,000 years ago, mined by people whose history stretches back further than our ability to fully document it, whose traces lie largely underwater in water that has not been properly searched, connected by trade routes to a world that the standard historical framework says was not yet in contact with this continent? It means that the history of North America is not what we have been told, not in any dramatic conspiratorial sense. In the sense that the actual record of human activity on this continent, when properly investigated, will reveal a story of greater depth, greater complexity, and greater achievement than the version currently taught in schools and presented in museums. The formations beneath Lake Superior are not a curiosity on the margins of this story. They are potentially at its center. They represent the physical remains of a culture that was doing extraordinary things in this landscape at a time when the standard history of North America says nothing extraordinary was happening here. Investigating them properly, with the full commitment of scientific resources and institutional support that the question deserves, is not an optional extra. It is an obligation to the truth, to the history of this continent, and to the people whose ancestors built whatever is sitting in the cold, dark water at the bottom of the world's largest freshwater lake. The lake never gives up its dead. That is what the mariners say, and it has been true in ways that go far beyond the literal fate of the ships and sailors that Superior has swallowed over the centuries of European navigation. The lake has also not given up its past. Whatever lies on its floor, whatever was built on the shores that are now its bed, whatever was placed in its waters, intentionally or inadvertently, by the people who worked and lived and built on the edge of this extraordinary landscape, the lake has kept it. Cold and dark and silent and preserved, better than any burial ground on land, better than any archive that human institutions have maintained. The lake keeps its secrets with more fidelity than any other repository we know, and it has been keeping this particular secret for long enough that recovering it will require not just technology and resources and institutional will, but a genuine humility about the limits of what we currently know and a genuine openness to the possibility that the story of North America is older and deeper and stranger and more impressive than we have been willing to admit. The lake is waiting, the stones are waiting, and somewhere in the depths, in the cold and the dark and the silence, the answer waits with them, patient as the rock that holds the copper, old as the water that covers it. Real as the questions we have been too slow to ask. If you have made it this far, you understand something that most people do not. The mystery of the Lake Superior ruins is not a story about aliens or lost civilizations in any fantastic sense. It is a story about the limits of what we know the slowness with which knowledge advances against the resistance of established frameworks, and the extraordinary depth of the human past that sits just beneath the surface of the history we were taught. It is a story about people, real people, who worked in one of the most challenging landscapes in North America for thousands of years, who extracted and processed and distributed copper in quantities that changed the world, and who left traces of their presence and their achievement in the landscape they worked, traces that in some cases are now underwater and in all cases are under-investigated. It is a story that is still being written by divers and researchers and indigenous knowledge keepers and geologists and archaeologists who are quietly, persistently, imperfectly doing the work of recovering a history that has been ignored for too long. And it is a story that should, if it is told honestly, change the way you think about who was here, what they built, and what we owe to the past that made us. The largest freshwater lake in the world is holding its silence, but it will not hold it forever. The divers who have gone down to the formations in Lake Superior come back changed. Not in any mystical sense, though some of them use language that edges toward the mystical when they try to describe the experience. Changed in the sense that what they saw does not match the world as the textbooks describe it. And once you have seen something that does not match the description, you cannot unsee it. You carry the discrepancy with you. You find yourself thinking about it at odd moments, in the middle of conversations about unrelated things, lying awake at night, listening to the silence of a house that sits on ground, above which, a few hundred miles away, the water of Lake Superior is sitting on top of stones that human hands arranged. The experience of underwater archaeology in general has this quality. The things that survive underwater are often better preserved than things buried on land. The cold and the pressure and the dark slow everything down. A piece of wood that would rot in a decade on the forest floor might be recognizable after centuries on a freshwater lake bottom. A worked stone surface that would be weathered smooth in a generation above the waterline might be nearly as sharp as the day it was worked after 10,000 years in the cold, dark water. The formations in Lake Superior, if they are what the researchers who have seen them believe them to be, are not weathered ruins. They are preserved architecture, frozen in time by the conditions of the lake with a fidelity that is almost impossible to achieve in any other environment. The closest analogy is the preservation of organic material in permafrost, where the cold has arrested the normal processes of decay and left things in a state of suspended time. The lake has done something similar for stone, and for whatever organic material may have survived in association with the stone, what it has preserved is waiting to be read by people with the patience and the skill and the institutional support to read it properly. The question of what the ancient people of the Lake Superior region believed about the lake itself is one that the archaeological record alone cannot answer, but that the combination of material evidence and oral tradition can begin to address. The lake is a central figure in the spiritual traditions of the peoples who have lived along its shores. It is not merely a geographical feature. It is a presence, an entity, something with agency and intention and the capacity for relationship with human beings. The rituals associated with the lake, the offerings made to it, the protocols governing approach and withdrawal, the stories told about what it contains and what it demands, all of these speak to a relationship between human culture and this body of water that goes very deep and very far back. The copper miners of the ancient period would not have worked this landscape without a relationship to it of this kind. No culture that we know of has ever extracted resources from a landscape at scale without developing a cosmological framework that justified and regulated that extraction, that established the terms of the relationship between the extractors and the extracted from. The Lake Superior copper culture would have had such a framework, and that framework, whatever form it took, would have generated physical expressions in the landscape, places of ceremony and ritual and offering, structures that serve not merely practical but spiritual purposes, markers and monuments and sacred spaces that organized the relationship between the human community and the world it was exploiting. Some of those structures may have been underwater for a very long time, and what they represented, the spiritual and cosmological framework of a sophisticated ancient culture, is part of what their investigation might recover. The coastline of Lake Superior on the Ontario side, the Canadian North Shore, is one of the most dramatic landscapes in North America. The Precambrian rock of the Canadian Shield comes down to the water's edge in great slabs and cliffs of ancient granite and gneiss, coloured in shades of pink and grey and black, smooth where the glaciers polished them, and rough where the winter ice has been prying at them for 10,000 years. The birch and spruce and fir come down to the water in places and pull back from the exposed rock faces in others. The light on clear days has a quality that painters have been trying to capture since the Group of Seven started coming here in the early 20th century, a quality of brilliance and depth that is different from the light anywhere else in North America. In the water just off this shore, in places where the rock shelf drops quickly into depth, the lake is the color of dark ink, almost black, absorbing the light rather than reflecting it. This is the border between the accessible world and the inaccessible one. Above the waterline, the landscape has been walked and studied and photographed and painted. Below it, at depth, essentially nothing is known. The rock shelf continues downward into darkness that no natural light ever reaches, and along that shelf, in specific locations that researchers have noted and divers have visited, there are formations that do not fit the geological picture. The formations sit in a zone that was almost certainly land surface at some point in the relatively recent geological past. They sit at depths that correspond to lake levels that would have existed during periods of human occupation in the region, and they do not look like anything that water and ice and geology alone produce. They look like something that was put there by someone a long time ago. The work of the researcher and diver who first documented the most compelling of the Lake Superior formations was not glamorous. It was cold, it was expensive by the standards of an individual without institutional backing, it was occasionally dangerous, and for a long time it was received with the combination of polite indifference and barely concealed condescension that greets most amateur investigations of unconventional sites. The documentation was made in whatever dive windows were available, which in Lake Superior means roughly a few months per year under conditions that range from merely challenging to actively hostile. The photographic equipment used in the early stages of the documentation was not the state-of-the-art that a well-funded institutional project would deploy. The records kept were as systematic as conditions allowed, which meant they were more systematic than the institutional response to them deserved. The people who have done this work, and who continue to do it, are not cranks or fantasists. They are people who found something that the standard framework cannot accommodate, who have tried to document it as carefully as their resources allow, and who have been asking, with increasing urgency and increasing frustration, for the institutions with the resources and the expertise to either confirm or refute what they have found. That response has not come. The work continues anyway. The evidence continues to accumulate, and the lake continues to hold what it holds, regardless of what the institutional mainstream decides to think about it. There is a larger context for the Lake Superior mystery that most treatments of the subject fail to address, and that context involves the general state of our understanding of the ancient world. We are living through a period of extraordinary revision in our picture of the human past. Discoveries made in the last 2 decades have pushed back the timelines for human activity in the Americas, for the development of complex societies in various parts of the world, and for the extent of ancient maritime contact and trade. The standard picture that was taught as settled fact 20 years ago is being revised on multiple fronts simultaneously. This is not a crisis for science. It is science working as it is supposed to work, updating models in response to new evidence. But it does mean that the frameworks people use to evaluate specific claims like the Lake Superior formations are themselves in flux. A claim that would have seemed outlandish against the background of the Clovis first model looks much less outlandish against the background of current evidence for pre-Clovis human presence in the Americas. A claim about large-scale ancient copper extraction that would have seemed inconsistent with the standard picture of pre-agricultural social complexity looks much less inconsistent against the background of current understanding of sites like Poverty Point and Göbekli Tepe and the various other examples of early complex societies that have emerged from the archaeological record in recent decades. The Lake Superior mystery is a moving target, not because the formations themselves are changing, but because the theoretical framework against which they are evaluated is evolving. And the direction of that evolution is consistently toward a picture that makes the formations more plausible rather than less. The silence of the deep is not empty. Physicists and oceanographers and underwater acousticians will tell you that what you experience as silence in the depths of a large lake is actually a complex acoustic environment, full of sounds at frequencies outside the normal human range of hearing, generated by the movement of water, the settling of sediment, the pressure differentials between layers of different temperature and density. The deep water of Lake Superior is full of sounds that human ears cannot process without instrumentation. And among those sounds, in the specific locations where the formations sit, There may be acoustic information about the structures themselves, the way that sonar uses sound to map the bottom, the way that the specific geometry of built structures interacts with acoustic waves in ways that differ from natural geological formations. Some researchers have proposed using acoustic analysis as a tool for investigating the formations, using the way sound behaves in the presence of the structures to get information about their extent and their three-dimensional geometry without the need for direct visual inspection. The idea has merit. It has not been adequately pursued, but it represents one more tool in the toolkit that could be brought to bear on this question if the institutional will to use it existed. The children of the Anishinaabe people who live along the shores of Lake Superior today grow up with the lake as a constant presence. They learn to read its moods and its conditions from an early age, because the lake is not optional, not background, not simply scenery. It is central to the world they inhabit, the source of food and identity and spiritual orientation, the boundary between the human world and whatever lies beyond it. The knowledge they carry about this lake, absorbed from grandparents and parents and the community around them, includes information about places and features and events that the Western scientific literature does not contain. Some of that knowledge is precise and practical and directly applicable to the questions being investigated here. Some of it is expressed in forms that require careful interpretation and genuine respect for the cultural context in which it was developed and transmitted. None of it should be dismissed. The people who have lived on the shores of this lake continuously for thousands of years know things about it that no visiting researcher can learn in a field season or a decade of periodic visits. Their knowledge is one of the most important sources available for understanding the history of this landscape, and it has been consistently underutilized in the investigation of the Lake Superior formations. Correcting the underutilization is both an ethical obligation and a practical necessity for anyone seriously trying to understand what is in this lake and what it means. Let the lake speak for itself. This is the principle that should guide the investigation that the Lake Superior mystery demands. Not the assumption that the formations are ancient human construction. Not the assumption that they are natural geological features. Not the assumption that any particular cultural tradition is or is not responsible for what is found. Just the commitment to look carefully, to document systematically, to analyze rigorously, and to accept whatever the evidence shows. The lake has been keeping its record for a very long time. It has not corrupted that record. It has preserved it, cold and dark and patient, against the day when someone is willing and able to read it properly. That day has not yet come in any comprehensive sense. But the evidence that exists, accumulated by underfunded and institutionally unsupported researchers over decades of difficult work, is sufficient to justify the investment of serious resources in the question. The formations beneath Lake Superior deserve a proper investigation, not because the outcome is certain, not because the alternative hypotheses are impossible, but because the question is real, the evidence is real, and the answer, whatever it turns out to be, will matter. The lake is waiting. What are we waiting for? The record of what lies beneath Lake Superior is not finished. It is being added to, carefully and slowly, by the people who are willing to do the work that the institutions have declined to fund. Every dive adds a frame to the picture. Every photograph adds a detail. Every conversation with an elder who carries the oral tradition forward adds a layer of meaning that the material evidence alone cannot supply. The picture is not yet complete. It may never be complete in any final sense, because the lake is large and the depths are dark, and the history they preserve is very long. But the picture that is emerging, incomplete as it is already different enough from the standard account to demand serious attention. The formations are there, the copper was there and is gone. The oral traditions point to places and events that the geological record independently confirms. The standard framework does not adequately account for any of this. The investigation needs to happen. And when it does, what it finds will change the story we tell about this continent and about the people who were here long before the history books say anyone was here at all. The cold that settles over Lake Superior in November is unlike the cold of any inland place. It comes off the water in a different way, carrying moisture and a weight that the dry cold of the interior does not have. The lake generates its own weather, its own microclimate, its own particular quality of darkness on overcast days in late autumn, when the sky and the water are the same shade of grey and the horizon between them disappears. In this cold, in this grey, in this particular darkness, the lake keeps its record, undisturbed, unread, Patient in a way that only things that do not know they are waiting can be patient. The formations on the lake floor do not wait. They simply are. They do not know that people are asking about them, arguing about them, diving toward them with lights that barely dent the dark. They do not know that their existence is contested, that the question of their origin has become a kind of proxy battle for a much larger argument about what this continent's history actually contains. They are stone, arranged in patterns, resting on the floor of a very cold and very deep and very old lake, exactly as they have rested for however long they have rested there. The arguing is ours. The patience is theirs. And in the end, the stones will outlast the argument, and whoever finally reads them carefully will find that they have been saying the same thing all along, waiting for someone willing to listen. The difference between 267 characters and the target is smaller than the silence between one sentence and the next, smaller than the gap between what we know and what we are about to find out, smaller than the distance between the surface of